So hi everyone, good morning. It's great to be here. I apologize for the minor microphone issue. So as we just said, we're going to be talking about Elastic Security this morning. Very briefly, introduction to myself. Just switch slide here. So my name is James, based out of the tiny island of Malta, not too far away from Ukraine. I got to be there last year, which is fantastic. And what I do at Elastic is I help our users, our community, our customers to implement Elastic in a security perspective. So I myself have been using the Elastic Stack for a very long time, close to 8 years now, and always in the security operations space. Obviously, there's always a bit of an overlap between DevOps, security operations. We've seen DevSecOps now these days. And a lot of people have been using Elastic in the space for a very long time, even before we ever started offering natively security solutions. So we're going to talk today about the improvements we've made and where we're heading. And most of this is going to be a demo. So I have a few slides, and then we're going to jump right into a demo. In case people aren't too familiar with the Elastic Stack, let's just talk a bit about a few of the components. So we have obviously Elasticsearch. This is our scalable, distributable data store. You can run this anywhere. We also have now things like Kubernetes operator, we have Helm charts, obviously Docker containers, any cloud provider you can think of. You can run Elasticsearch anywhere, which is fantastic, as well as the other components which go to the rest of the stack. So of course we have Kibana. So this is the way we interact with the data from a UI perspective. Obviously we have all the APIs, but from a security analyst perspective, most of the time we're going to be working within Kibana. Kibana these days has also grown to be more than just visualizations and searches. You can also manage and monitor the entire stack throughout Kibana. Of course, for security and DevOps, we need a way to get data inside of Elasticsearch. So we have quite a few ways to do that, which we call our ingestion layer. We have our beats, which are very lightweight data shippers written in Golang. These installed on any operating system you like. Again, very cloud friendly and cloud native as well, so they can run in Docker containers. You can run them as Kubernetes deployments, whatever you like. There's also the concept of things like auto discovery for both pods and containers. So as you're adding more of those into your environments, they automatically get picked up. Things like their metrics, their logs. So we'll make it very easy for you to spin up as many of these beats as you need. There's multiple different beats depending on the data you want to collect. So we'll be looking at things like server logs and web server logs as well, Windows events, packet data. We have modules for things like EC2 and GCP and Azure. So there's a ton of different modules depending on the data you want to collect. Today, for this demo, we'll be focusing on obviously security related data. We also have our endpoint solution now. So a few months ago, we joined forces with a company called Endgame, which had been doing endpoint protection, detection and response for a very long time. So we actually have those capabilities now within the stack as well. So not just data collection, but also the ability to prevent and respond live to certain threats. For the demo, we're going to be focusing more on the beat side, but just to point out that this is also a really fantastic way of not just taking action, but getting telemetry and all this data inside of the stack. We also have Logstash. So Logstash is what a lot of people are familiar with from the data collection side. Logstash is more of a server-side component. So you set up a Logstash server, then you can stream data via syslog, TCP. It has an HTTP poller to query APIs. You can look up relational databases. You can pretty much do whatever you want with Logstash. It also has the concept of multiple outputs. So as data is coming in, you can transform it, you can add to it, you can adapt it, but then you can also output it to multiple locations. So it's pretty fantastic. We also, of course, being an open source product, we leverage the community very heavily. So like a nice advantage you get from using Elastic, apart from it being mostly free and open source, is people contribute back. Especially in the security world, we have this problem where we tend to be really siloed and we don't tend to share information. We change that. So everything we do is open. All our detection rules are open. The way we do machine learning is open. And people give back. Today, for example, we're going to use Windows sysmon configuration from the community as an example. So you can literally Google Project X, GitHub, Elastic, you'll find something. And of course, now you see the security box up there. That's basically talking about how, listen, we've learned that there's so many people using Elastic for security and not just observability. What can we do to make their lives easier? So there's a tremendous amount of content you get out of the box. So whether that's dashboards and views and machine learning and detection rules. So there's a lot of stuff that we get out of the box these days, especially for the security case. Those are my slides. I'm going to dive right into a demo. And just to give you a bit of context into what we're going to see, here's sort of a really small diagram of the environment. So I have a Windows machine running in GCP, so standard Windows Server 2019 image. So nothing special there, literally what you get as standard. I am running 2 beats there. So I have packet beat, which is looking at packet data on the wire. So literally whatever is going over my GCP interface, it's being picked up, sent straight to Elastic Cloud, which is also running on GCP. We have WinLogBeat, which is looking at the Windows events. But I also have Sysmon installed. So for those of you who aren't familiar, Sysmon is, think of it, I like to reference it as like the audit daemon for the audit daemon equivalent for Windows. So you can get really in-depth information about what's happening on a Windows system. And I'm using a community configuration thanks to Olaf Hartong, which is mapped to the MITRE ATT&CK framework. MITRE ATT&CK is a attack taxonomy, as we like to say. So it really helps you categorize what's going on into tactics and techniques. So as someone doing a hunt or an investigation, it really helps you narrow down into what might be happening on my system. And you'll see this theme Elastic Stack wide. So we're very focused on MITRE. Again, it's an open framework, which is fantastic. So everyone can use it. And it's been adopted all over the industry and community. That's a bit of background into the environment we're going to be using. So I'm just going to dive right in here. So let me switch to my Kibana instance. Let me zoom in a bit. Right, perfect. So just so you see, I have here the Windows machine, just so you can see it very quickly. It is a bit zoomed in. But what I did here, I detonated a malware sample. So this was a real malware sample. It's coming from the Helix group, also commonly known as APT34. It was sent via phishing email. So you can see this is the email someone would have gotten. You click on the attachment, it runs a Word document with several macros in it. So this actually ran on this machine, and then we're going to be able to see what we've detected, and we're able to investigate based on the data we're collecting. If anyone's interested, I did extract the macros that are running on that machine. I don't know if it's coming clear on the screen, but there's quite a bit going on here. So it was a very clever bit of malware, and I did extract them. If anyone wants to see them, it's a publicly available sample, so I just took the work of extracting them for users to see. I'll also mention that the configuration we're using for the beats, so both packet beat and winlog beat, is what you get out of the box. So you download them and you run them, and you don't have to make any changes. So it works pretty much immediately. The same for the Elastic Stack. So this is running in our cloud environment. So you can see here, it's running in GCP in our cloud. So we do have our own SaaS service, but you can run this wherever you like. You don't have to use our cloud. Any way you like, either hosted in your own private clouds, again, any cloud provider, when most of the marketplaces as well. You can spin up your own instances, run it in Docker, wherever you like. You're going to get the same experience. So the same features you're seeing here, it's not like cloud specific or anything like that. But it is the out-of-the-box content. So as soon as you run this, you're going to get the ability to do this without having to do many changes. So I haven't spent months of writing my own rules, building my own views. I am just using what is provided out of the box. So this is Kibana. I'm sure some of you are familiar with Kibana. There's many different views that we have these days, including several different tools used in the DevOps community. So metrics, APM, logging. There's a tremendous amount of tools used there, uptime as well. For most of this demo, we're going to be in SIM, but we'll talk a bit about the others as well, specifically things like Canvas and Maps and how they can be used in security. So right now I'm in Kibana and I click on the SIM. You're presented with an overview page. So as an analyst, I go in here, or as a a security operations manager, I can go in here and get an overview of what's happening in terms of my security posture. Of course, the same concept of Kibana wide, we have a search bar, so you can search at any time throughout the entire app using the Kibana query language. Obviously, a time picker, so we don't restrict you in how much data you store, how much you want to search for. You can search across as much data as you need or like. And then we start with, hey, here's what's going on. So first of all, we start with what we call signals. Signals are pretty much alerts. So what is happening in your environment, either based on the out-of-the-box detection rules, like we're going to see here, or maybe any rules that you've created yourself. So you can see here, basically, hey, here's what's being triggered based on the data I have in my environment. And we also have external alerts. One of the beauties of the Elastic Stack is we don't necessarily care where you get your data from, right? If you want to use our beats, fantastic. If you want to use our endpoint, that's great. But if you have your own endpoint product, please feel free to use it and take in the data. We have no problem with that. If you prefer using syslog, rsyslog, nxlog, syslog-ng, fluentd, anything you can think of to get data in, we have no problem with that. So if you have another device on your network or another bit of software that is generating its own alerts, you can send those to the Elastic Stack and we'll visualize them as external alerts. So you can see here, for example, I have Suricata as one of my other data sets, which of course has its own rule sets, which is fantastic. So, and they're being picked up as intrusion detection events, as an example. So that's why there's two different tables here. Think of the top one as, here's what Elastic has detected and the inbuilt detection rules, versus here's what my other devices and software have detected on my network. We get a breakdown of all the events we're receiving. So even though the attack that we ran and that sample ran on that Windows machine with the Windows events and the packet data, I have more data coming in here. So I have things like audit beat on my Linux systems and Mac OS as well, looking at the audit daemon framework. So we're doing all the parsing and username mapping. This will work, by the way, for any Kubernetes or Docker environment as well. We actually released a feature where you can run file integrity monitoring inside of Kubernetes pods as an example. You're looking at logins, packages installed. So there's a lot of information coming in. Of course, we have Windows events. I'm collecting quite a few different things with FileBeat, like Nginx logs, IP tables, SSH. We have packet data. We have, again, Suricata events with FileBeat. So there's quite a bit going on here. I do have our endpoint installed as well. So we'll be able to see what the data coming from there looks like. But I wanted to focus this more on community-related data sets. So apart from the breakdown of events that we get, we have a few recent items. So in this version, the 7.7 version, which is what you're seeing here, we introduced the concept of case management, which is pretty cool. So now within the CM, you can start a collaborative incident response process. So other people can comment, you can put artifacts, you can do whatever you like, and we keep track of all these recent cases there. We also have recent timelines. So timelines are basically investigations. And we built a really easy way of carrying out an investigation with drag and drop. So I will obviously be talking about that quite extensively, but now any recent timelines that you have will show up right over here. And lastly, on the overview, there's a news feed. So at Elastic, we have a very large detections, protections, and research team. So their job is literally looking at malware samples, writing detection rules, seeing what's relevant and about attacks happening today. How can we detect them? How can we prevent them? So anything they're working on, they have the ability to write a blog post and publish it straight to the analyst. So we wanted to avoid the situation where it goes out as like a marketing email or a sales email. We really wanted a better way to give this information right to the analyst. So we publish this news feed, so it goes straight to the people who should be using it, right? So it doesn't get lost in your emails that you're probably sending to junk because they're marketing emails. So that's the overview page. So just a really quick breakdown of that. Let's see what we were able to detect. So I'm going to switch to the detections view. So you see you have the detections as one of the menu here. I did preload this just because I have a saved time range. So I ran this sample yesterday. I just want to show you within this view what things an analyst can start to do to investigate. So I have here similar to what we saw before, the detected signals. And even as I look at this table, right? So let's switch this to, let's see the rule names rather than the severity. And we can see here there's sort of a pattern. So the nice thing about having these visuals is sometimes you can immediately tell that there's something suspicious because, hey, we had a very big flux of alerts here. And then there's sort of this persistent, repetitive pattern of the same alerts triggering all the time. So it just gives you sort of a visual indicator that this might be something I might need to look into. Well, of course, we do have all the signals or alerts that are being triggered at the bottom. You'll notice, so if I hover over some of these, again, these are out of the box, right? So I didn't create these myself, only one of them, and I'll talk a bit about which one. But we have things like Windows script executing PowerShell. We have DNS tunneling, which was detected. We have a few others. If I keep scrolling down, you can see here, but there's a repetitive pattern. So a lot of PowerShell executing and then DNS tunneling. It might get you thinking. If I scroll down more, there's things like scheduled tasks being created, some adversary behavior. So there's a fair amount that was triggered here. But we also notice that they're all happening for the same host. I'll just let this refresh in a second. But you see here the host name is the same. So we also give you an indication of, hey, this is happening on the same host. So as an analyst, I have a few decisions I can take here. How do I start doing root cause analysis and looking into these events? So we have a button here immediately that allows you to grab this alert or the data associated with this alert and investigate it in the timeline. What is this timeline? So if I click on this, you'll see this pop out here, and it's going to filter for the specific rule ID. And it basically gives me the event that generated that rule. And you'll also notice that it's in yellow. And this in particular came from sysmon. So if anyone's recognizing the process create messages from sysmon, I can open this up. I can look at the full event. So for example, here we'll notice that there's PowerShell running, there's some arguments. We'll see the parent process is actually the W script. So I can investigate it this way. However, if I was an analyst, I probably wouldn't go through each and every single one, right? Especially since they're all for the same host. So one thing we can do is we can dive and drill into that particular host. So why don't we do that? I did that here just to focus on the time range, but when I click into a host, I get a whole lot of metadata about that particular machine. So it's not just the individual events, but hey, give me everything you can about what this machine is. So for example, this is running in GCP, so I get that it's running there, I get the instance ID, what machine type is it. Sometimes these are really useful to drill down. If someone's focusing an attack, for example, on a particular machine type, or you have a machine type that your company typically doesn't use, maybe you're not using the N1 series, you're using something else, that's going to show up here for you. So you can immediately see what that is. And this is true for any cloud provider. So automatically in the background, it's trying to query the native SDKs on the machines. So like whether you're using AWS, GCP, Azure, DigitalOcean, you're going to be getting all this information as well. We have all the operating system info. So again, this is Windows. We'll see the IP addresses, any MAC addresses, so on and so forth. You'll also notice here that there's this anomaly score. So apart from those static rules, actually you saw in there that one of them was triggered by machine learning. If you notice, let's go back really quickly. This DNS tunneling wasn't a query-based rule, it was based on machine learning. So apart from the out-of-the-box rules that you get 23 machine learning jobs, which are very different because these are unsupervised learning. So they're looking at this data and they're modeling it over time. So apart from you seeing the results here in the same detections table, we summarize if there were any machine learning anomalies happening on that machine. And if I hover over this one here, this is telling me that, hey, we noticed a potential event for DNS tunneling here. We can get into the information about how it was detected, but as an analyst, I get an idea now that, look, not only am I getting static events from my rules, machine learning has also modeled strange behavior. And this is around DNS. So we saw, there was a lot of PowerShell and then a DNS exfiltration attempt. So that might get you start thinking, hey, what is causing this DNS exfiltration? Before we get into more detail about this, if I was an analyst, again, I have some views that will help me start doing more investigation. So I can see my users that authenticated and how many times and from where. I can get things like uncommon processes as well. So if I'm looking at uncommon processes, I get the user context. So I can see, hey, who the heck is this James Spiteri, right? So I can see a lot of James Spiteri. I can see that there's scheduled tasks running and all the arguments, which is a bit suspicious. There's command prompt, which opened scheduled tasks. So you can actually see the parent process of scheduled task was command prompt. There's things like Word, which this might be normal. However, this is Windows Server, so why is someone running Word on Windows Server? PowerShell and all the PowerShell arguments, WScript. So if I wanted to start like focusing my attention based on the uncommon processes, now that we've seen that, hey, there's all these detections trigger, there's machine learning jobs trigger, let's start investigating. And I can start by the uncommon processes. Or maybe I want to start by the authentications. Or maybe I want to start from the results. So you as an analyst have a choice in terms of how you want to start investigating. For me, if I see events happening across the same host, I like either doing a user context-based search or something like a process context-based. So for example, let's say we saw 138 instances of PowerShell in that time period, and they all have the same arguments. So what we could do is let's focus on the PowerShell stuff. So I'm going to open up the timeline again, and very simply, I'm going to get PowerShell and drag it into the timeline. So we wanted to make it easy. So if you're not too familiar, for example, with the query language in Kibana, we've also given you the option to drag and drop. So you have the choice. If you do like manual queries, you can do that as well. So again, you're not restricted here. You can search in any way you like. I'm a big fan of this drag and drop stuff because it just gets me started very quickly. You'll also notice that the beauty of Elastic, as we all know, is we're not waiting for data or we're not waiting for events, right? So these came up immediately in half a second. Another nice thing about the timeline is the way it shows you the data for certain events. So yes, there's a lot of the process create here, and you can see they're marked in yellow, which means they were involved in detections. But for certain data sources, we do what we call event rendering. And this is especially true for the audit daemon events. I'll see if I can show you some examples, but look how easy it is to read. Whereas before I had to open this up and go through all the fields, which there can be a lot of, right? For certain events, we render them like this. So it's like a story. So it's basically saying, hey, James, in this domain on this host, terminated PowerShell. This is a hash of the process. Or for those DNS requests, right? Look how easy this is. So like, again, it's telling me exactly what happened. And as I'm going through this, I can add more elements here that are relevant to my investigation. So I don't have to drag a one drop one thing, but for example, we saw before in the PowerShell arguments that there was a bypass in there. Why is someone trying to bypass the execution policy, for example? So let's do a manual search in this case. I can do something like process.args, and you can see there's like suggestions here as well. And let's search specifically for bypass. And if I leave this long enough, it'll actually give me suggestions of the values as well, like we're seeing here. But I know specifically I'm looking for bypass, so I can do bypass. And now I'm only focused on the events where I had PowerShell running with that specific argument. And you can see here pretty much what I expected to see before. So I can see that script, that's the parent process. So I can narrow down my events more to, I can do whatever I like. And again, we're not waiting. So as I'm changing these queries, as I'm going through this investigation, I'm not waiting at any point, which is, again, the nice thing about Elastic. Let's add one more thing here. Let's add where the parent process was WScript, right? So let's not use the endgame data. Let's use a sysmon event. So I can go in here. I should be able to see the parent process. This is something sysmon does really well. You'll also notice, if I scroll down here, we're going to see certain fields around threat. So remember that configuration that Olaf put together has the MITRE ATT&CK tactics and techniques included in there. So if I wanted to, I can do a search for technique T1068, for example. I can throw that in my query. I can also enable this column. So if I wanted to, I can toggle this column, and now I have the threat ID, the threat tactic, the threat technique ID in there as well. So I have a choice. Like one of the advantages of Elastic is enriching data on ingest. So whatever tool you use, whatever beat you use, you can do that. In my case, because the data, it's part of the data set, it's done for me. Then I use a this is the only bit of custom work I did that grabs the fields and just transforms them into these three things. So I have that choice as well. But if I scroll down, I'll be able to see the parent process here was WScript, right? So it's similar to what we saw before. So maybe I wanted to add this into my query just to make it narrowed down a bit. So I can, drag that in, add it. You also get the choice of doing an and or an or query, so you can make this really a sophisticated search. So I'm going through this. We already narrowed down that there seems to be this repetitive process of PowerShell launched by WScript. We'll also notice that there's a lot, it's all based in this Windows app pool directory. So both the WScript stuff and the PowerShell stuff, they're all running out of this Windows app pool directory. So whatever this malware did must have created that directory and is just trying to run out of there. So technically, I don't think we have enough time to do it in this particular demo, but I could go and look for those file creation events to see if that directory was created and then those files were created as part of the sample. So if I wanted to go and narrow that down further, I have the data to do it. Let's focus on these three elements right now. So let's say now that we've had Elastic tell me, hey, there's something strange here. We've done a bit of investigation and we've narrowed it down to something like these three suspicious elements, for example. Let's say we wanted to create our own detection rule based off of this, right? So even though, yes, we have our own, maybe I want a specific detection rule for this particular event. We can save this query and we can create that. Before I do it, I'm going to leave some notes here. So then if someone else comes and looks at this investigation or this timeline, they can see exactly what I did. So in this, we allow you to leave notes either at an event level or at an entire timeline level. So I can do something like, hey, this is suspicious. And we support, full markdown syntax here. So if you want to leave screenshots, GIFs, images, whatever you want, we support that. You can add the note, and it just leaves context for anyone who's coming to follow up after this particular investigation to say what James Spiteri has done. You can also leave notes at an entire timeline level. So if you wanted to leave like a generic note for the whole investigation, you can do that as well. By default, these timelines are automatically persisted to Elasticsearch. So in the background, it's writing them to the Kibana indices. But if you wanted to give it a name, you can. So even if you don't do this, it gets saved. But if you wanted to give it a name to help, so for example, DevOps Fest demo, we can do that. You can give it a favorite. You can do whatever you like. And now I'm going to save this query. So I'm going to go ahead and save this query, which is going to allow me to use it either to create our own detection rule, like we're going to do, or to use it in any other part of Kibana. So if another team wants to use this on their own custom dashboards, or maybe they're using them, like they want to see if PowerShell is generating specific, like very high CPU. So my DevOps team can see it, my infra team can see it. Like you can use this query throughout any other part of Kibana, as long as the permissions, of course, match. So let's save that. And now let's go ahead and create our own detection rule based on this, right? So it's like we're going full circle. We had the Elastic tell me there's something wrong. I did some investigation. Now I want to create my own rule to always let me know when that behavior is happening. So let's go ahead and do that. Let's go to the detections page. And you see here we have a button for manage signal detection. So when I click on this, first of all, we can see all the rules that come out of the box. So there's, I think, about 130 for this version 7.7. And these includes rules for the 23 machine learning jobs as well. So you get the best of both worlds here, like we saw before. But in this case, let's go ahead and create our own. So we can go and create a new rule. And you see, when I go to create a new rule, I have a few options. So I can either do it based off of a custom query or a saved search, or we can also do it based off of a machine learning job. So like the one we saw before for the DNS tunneling, this is how it's set up. So I can have several machine learning jobs across all of Elastic. I can pick one, pick the threshold, and then create an alert for that. So that's also built right into this. In our case, we're going to do it based off of a custom query. And you can see by default, it's going to search across all my data sets. That's also important to note for the timeline, because as soon as I did this search, this basically ran the same search process name PowerShell.exe, for all my hosts across all my environments, because here we're using Elastic Common Schema. So basically, it's a field naming convention to work across all of Elastic. So whether I have data coming from metrics, from our firewall, next-gen firewall, maybe that's picking up process names, my endpoints, anything, it's going to search across all of it, which is really nice. And this works in the same way for the rule creation. So now, if I needed to narrow down these indices, I can. So maybe I know, for example, that in this case, audit beat is irrelevant, so I can take it out just to narrow down that query. But let's leave it like this, just for the demo's sake. And we can load up the saved search we just did. So we should be able to see here DevOps Fest, which is going to have that timeline filter drop area. So anything I threw into the timeline, as well as anything I typed into the custom query box, so into the query box. So I can do the best of both worlds. If I wanted to narrow it down further, maybe I only care about, for example, and destination the bytes, for example, is greater than 100. Maybe I'm only interested in something like that. You can do all of this stuff as well. For this demo, we're going to leave it as this. And you can see here, there's an option to pick a default blink timeline. You know, the first thing we did within the sim and the detections is I clicked on this button and it opened up in the timeline and it filtered for that specific rule ID, right? However, this isn't the best view. Maybe for a certain rule, I would prefer that as soon as I click on that button, certain filters open. And this is what this is referring to. So if we pick here, for example, the timeline we just worked on, the DevOps flow, this is going to, when I click that button, it's going to open up with all those filters. For an example, for the DNS tunneling, if I click on open in timeline, there's going to be a filter there which filters for type DNS, right? So like, I don't have to start from scratch as an analyst. I have already some predetermined filters. And also if I want predetermined notes, which is quite cool. So like it really helps to narrow down the time I need to make an investigation. So added in our timeline template there. Let's hit continue. And now we can give a description about this rule. Rule for DevOps Fest. We can give a description. Script as a parent, for example, parent process. You can give it a severity rating and a risk score, for example. We can add tags, anything we want. So we can put like PowerShell. I can put in WScript, APT34, whatever I want. And then under advanced settings, there's even more information. So I can put in things like reference URLs. I can put in false positive examples. I can put in the MITRE tactics and techniques. So we built those right in. Here I'm inventing, obviously these don't match, but I can put whatever I like. We also introduced the concept of an investigation guide. So I'll show you an example of this one, but let's say my analyst has never used Elastic before, has no idea how to investigate this particular incident. We can actually put that right in there as well, which is pretty cool. Press continue, let's choose our schedule. So everything you're seeing here, by the way, this is a brand new alerting framework in Kibana. So you can use this for any data set. And one of the things we built in new is the ability to have obviously a UI, because before it was all based on Watcher. So there is an API behind it, but we made it easier to use from a UI perspective. So you see here my schedule now as the next step in this. So it's going to run every 5 minutes with 1 minute look back. What this means is if for some reason my my ingestion is delayed a bit, maybe there's something wrong with my Kafka pipelines or something like that, we can say, hey, run every 5 minutes, but look at the last 6 minutes worth of data. So we can do that. And again, this is totally customizable. If I press continue, we now have also the concept of actions, of course. So not everyone has the ability to stay in front of a screen and look at this all the time, especially in our world where we're moving more and more towards automation. We can't have more people in the loop. We can now take action. So you can see here, there's some actions, so email, PagerDuty, Slack, webhooks, so any generic RESTful API can be used. So for example, here I have a API connector already. I can add a new one on demand. So just give it the API endpoint, any headers that you need for authentication, username, basic auth, things like that. And then you can put in the post payload. So you can put in the body. We give you variables to use. So if you wanted to craft this rule based on certain elements within the rule that's being triggered, you can throw those right in. You can also have multiple actions. So let's say, for example, when this triggers, you want a Slack message, but you also wanted to kick off some pipeline, for example, to start doing something else. That's something you can do, right? Then you have a choice. If you're finished, you can create and activate it, obviously. But if you're not ready, maybe you're still modifying your post payload, maybe you're still modifying your query, but you need to come back tomorrow, maybe you can create the rule without activating it. So it's like a save button, and you don't have to deploy it before it's actually finished. A lot of people, of course, in production, this is going to go through like a rule approval process. So since there's an API behind this, quite a few people will actually commit these rules via API, like again through like a GitOps pipeline or something like that. And so you have that capability if you needed to. Everything you're seeing here, there's an API behind it. But the random rule that people will create, of course, this is fantastic. So that's what the rule creation process looks like. So we did a bit of investigation based off of the rules that were triggered. We went in and then created our own rule based on the investigation that we did. What I'll do is I'll show you some examples of what it looks like when you open up a rule. So right now, we didn't even click on any of these links yet, right? So I just went straight into the detections menu or the host menu. If I click on one of these links, it would actually give me all the information about that particular rule. So this is that DNS tunneling one. You can see all the information. So as an analyst, I can see this immediately at the tip of my fingers, like it's just there. All the MITRE tactics with the links. So these are automatically linked back to the MITRE website. Since this is running off of a machine learning job, we can see the link back to machine learning in Kibana. So we do have a dedicated machine learning view if you wanted more details. And it tells you the status of the machine learning job. So this machine learning job is running, it's modeling in the background. For those of you who are interested, this particular job, what it's doing, is basically looking at every single DNS request, and it's modeling the length of the subdomains per top-level domain, so per registered domain, right? So what it's trying to look for is, hey, does a certain registered domain, so like our withyourface.com, does it have multiple very long subdomains? So it's actually modeling the length and the frequency and the occurrences. And in this case, as we saw before, there were loads of DNS requests for the same domain. So it picked it up successfully. Again, this was a real malware sample, which actually did DNS tunneling. So it's pretty cool. Again, these are all documented on the website if you need. So if you need more information, there's everything exactly what you're seeing here documented, just in case you need more details. So we don't hide any of this or what we're doing, but just to give you a bit of background. I also have an example here of an investigation guide. Again, we support Markdown syntax here. So I put in things like GIFs and screenshots and so other parts of Kibana. Again, like just use everything you want to your advantage, and you really rich. If someone has never used this before, now they have a really nice investigation guide natively within this view. I also have here, let me just drag it over from my other screen, an example of the alert action. So this is my Slack bot here. So I put in some Slack buttons and other links, but this is the data generated from that same alert using those variables, which is pretty cool. So like, again, you can have anything you want here. There's no restriction. So just to give you an idea of what you can build based off of those alerts. The last thing I'll talk about, just have a couple of minutes left, is what happens if I need to, that investigation we just did, right? So far I've investigated alone. What if I wanted to start involving other people? So we also have the concept of case management here. So let's say I reopen the timeline. So you can see here, this is the timeline we were just working on. Let's open that up again. And you know what? I want to create a case based off of this timeline. I've done as much as I can, but maybe now it's time to hand off to the endpoint team or the network team to start doing some cleanup. So within this view, I can immediately hit attach timeline to a new case. And what this is going to do is it's going to open up this case management view. It's going to, excuse me, it's going to link in this timeline. And you can, again, it's typical Markdown syntax, so you can put in whatever you like here. And we have a nice button to add any other timeline that you want. So if you did multiple investigations per case, you can just include them in immediately. So let's give this a name. Again, let's call it DevOps Fest, fun case. You can, again, have the concept of tags, create case. And now I've basically started an incident. Other people can come in here, they can collaborate. You can have multiple participants. And each comment supports Markdown. You can have copy the reference link to this particular comment. You can quote it. You can see the status. And also, we've built right in native capability. For example, if you're using a ServiceNow, or any especially specifically ServiceNow ITSM for this release, you can have it push automatically as a ServiceNow incident. So if you wanted to keep track in both places, you can do that. And setting that up is, just another menu option. So you go to Edit External Connection, and you can add a ServiceNow. There will be more we're adding in the future, but so far for this release, it's ServiceNow. And I know for things like Jira and other popular tools are coming up. For this release, it's ServiceNow. So the last thing I'll show you, we're just about wrapping up here, is, I said, hey, we can use other parts of Kibana, right? So for example, let's say I wanted to build a Canvas workpad based off of that MITRE attack data. So maybe not everyone is comfortable starting from the SIM. So Canvas is going to use the same exact data that we were seeing, but visualize it differently. And Canvas is fully interactive, real-time data, so you have it refresh. So it's not static data. It's not like we run report once, so it's going to do the same queries in the background. You can have drill downs and dynamic links. So these will actually open up in the SIM as an example if I do that. So you can have anything you like here. We also have the concept of having multiple pages. So I can see if anything triggered here in terms of detections, in terms of anomalies. I can maybe look at my timelines in this view. Maybe I want to link out to other tools. As much as we say we can do a lot of it in Elastic, but obviously there's always going to be some other tool we use. Maybe I wanted to run some pipelines. So we can do a lot right within Canvas. So it's pretty cool. A few more things, of course, using that data on a map, for example. So in this case, since this is a DevOps conference, I built this demo. Basically, what I'm doing is I'm combining it with my metrics from my hosts. So as I have traffic coming in from SSH, IP tables, and Nginx, I'm also checking at the same time to say, hey, what's my CPU usage on that host? Am I receiving enough traffic that my CPU usage is escalating? And you can see here there's an average CPU system total that's joining the data from metric beat. So we've made that really easy within maps, so you can actually just join across other data sets. And because we're using that Elastic Common Schema, this is very easy. Of course, and then there's things like our graph. So if you wanted to look at relationships within the data sets, so for example, here I'm grabbing all the detection rules that are being triggered, and I wanted to see the relationship between the name of the rule, the host, and the MITRE attack technique. So I can add in any element that I want in here to see what relationships there are between the different data elements. So that's just another example. Of course, there's way more and a lot more you can do. The key is having the same data in Elastic and use it across multiple use cases. So in fact, for example, we have rules for APM data inside of the SIM. So you can do whatever you like. Perfect. So that's it for my demo. So thank you all very much. And again, thank you for the invitation to speak at DevOps Fest. I think we have a Q&A now, right? Am I correct in saying that? That's where there's a Q&A session just after my talk ends. So I'm happy to take any questions there in the time I've provided.
Yeah. Hi back, James. Thank you very much for your talk. We appreciate a lot that you joined our conference. So guys, please ask your questions in chat and I will read them to James right now, if you have anything to ask. And if not, you can join the Q&A Zoom room of track number 2 just after a couple minutes after the talk. And you can turn on your video, audio, and have a live discussion with James and ask all you are interested in regarding the security in Elastic. So let's wait 1 more minute. Maybe
Sure.
people are typing
No problem.
long questions. Okay. Okay, looks like we don't have much questions in the chat. So again, remind you guys to join Zoom rooms. James will be there in a couple minutes, so you can ask all your questions there. Thank you once again. We were glad to host you even online and hope to see you next year welcome you next year in Ukraine.
Absolutely.
Thank you.
Thank you, everyone.